Welcome to my video demonstrating the new open source project rx5808 Pro OSD. This is a mini tuner based on Arduino with a rx5808 receiver module with SPI patch. In January I did the same thing without OSD, and this one is now with OSD. My setup here is I'm just filming my ground station with my, I think, 12-inch TV set. It's just showing an image received from my receiver. I have here 3 control buttons at the top where I can control it. And to demonstrate it, I have 2 cameras. This one was the second one. So the nice thing is right now everything is tuned. You see just the image from the receiver. When I press a button, the OSD will show up. Right now I'm in the linear tuning mode. You see the spectrum, and what you just see, you've seen that the image disappears after a few seconds. So I will click this. So you have set up with the spectrum here, you have the frequency. Right now it's tuned to channel E. You have here the live signal strength. We have the voltage of the battery up here, you can see, because my stupid monitor is always creating this AV1 overlay here. Since this is band E, it's also some markers here at the down what shows all the different E possible channels, and this arrow here shows the current tuned position. When I press the mode button for a few seconds, I will come to a special setup menu. Here we have different functions. With mode I can move here and the different menus. Exit will leave this. Auto search is just a searcher, as it says. Band scanner is a spectrum analyzer. Manual mode is what you have seen, and we have a setup here. Let's just enter the setup to demonstrate it. By the way, by pressing the mode, it's just moving always the way down, then it jumps up and again. So I will use go to select, press the right button. Now I have a second menu. Here we have exit. We can save the current settings. We can change the manual mode between two. I will demonstrate later. Then we have the video mode. You can choose between PAL and NTSC. You can calibrate the receiver signal strength indicators, and you can upload a font what is required for the initial setup. Let's exit here. So I choose exit, press the right button, and I'm back now here with auto scan mode. Let's wait until this disappears, because then I can show you how this is done. So right now you see a filmed paper here what demonstrates the setup of the receiver itself. I created a GitHub project with pictures in it, diagrams, source code, documentation. Everything is available for you right now, but this shows you just how the structure is. So the nice thing is this is very compact, because the basis of this is a minimOSD with an Arduino bootloader on it that makes it very small. The nice thing is it comes with a CPU with a OSD chip on it, and it is also a switching power supply what can be used to power the tuner. Here on the picture you see the tuner on the back side with this is the known Boscam rx5808 tuner with SPI patch, and a test antenna. You have a power supply here. This is a video out, and for firmware updates I added a 4-pin connector over here. And for controlling, I have just a keyboard here with 3 buttons. What is connected with 2 wires, and this exact electronic is currently working in my ground station. And these 3 buttons over here are at this position, and the update connector here is just living here, just that you get an idea of what I've done here. So let's just go through the menus and show how it's working. First of all, when I do nothing, the OSD will hide in the background. When you press a button, it will reappear. One special thing on OSD you should know is OSD requires syncing to an external video source. So the problem is, if your video source gets crappy because of bad receiving condition, it may happen that the OSD is not syncing and will not show everything. because of tuning, you have always a situation that the signal will go and or will appear or disappear, syncing will go bad. That's the reason why you will notice when I demonstrate here that sometimes the menu will appear or disappear. This is just because the chip must sync again or resync, will lose sync. Anyhow, people working who know OSD will know this issue, but it's from my point of view okay. If you don't like this after your signal is tuned, you have always the option to bypass the OSD signal. Means you bypass the receiving signal directly to your monitor, then the OSD will not disappear. It will disappear. But bottom line is, I use it that way and it works fine. So I will press a button for the middle button for a few seconds to come into the mode menu. The image just disappears because in the mode menu I made it this way that it uses internal sync, and I will go to auto search first. So when I am at this position here, I press right button. This will select it. What it does at the beginning, it will scan the band very fast in 1 second, gives the current spectrum here, and let me just press the button again. And right now it's tuned at channel R7, but since the signal strength is very strong because the sender is just sitting next to me here, it's this signal here. I will just press the right button now to seek again. So it's jumping one further. By the way, it's really E5 right now. One further, it's going through the band. You may notice that the image will appear and disappear. That's because of the video syncing. Press again. Right search. Now I go left search. And here we are back again. You may notice that the seek will stop at this signal because it's very strong, but it will skip this one because this one is some meters away from me. The interesting thing is when you enter this mode, it will when it does initial scan, it automatically sets a seeking maximum signal. That means because I have a strong signal here, it will find only the strong one and ignore the less strong signal. I will turn off this sender right now by plugging the cable, and you see it's gone now. Now I press the seek again. It will still not find the signal. What I do right now, I choose auto select again to calibrate the system back. Calibrate the system again. Now it will stop at this signal. It's slower. It's lower than the previous one, but now it's good enough to get a lock on the seek. That means when you're in the field, there's no need to calibrate the signal strength. It does it automatically. Right now, my setup is really to have a strong and a weak signal to demonstrate how it works. Let's see what else is here. When we are in when we found a certain frequency, it's always telling you this is band E right now, channel 1. You have the signal strength here, and in any menus, when you select a channel, you may notice the text here at the bottom. This shows the other channels in this band. For example, the E1 is here, the E2 is here, E3 is here, E4, E5, E6, E7, E8. And as you see, it's interesting is that really depending on the band, the frequency are mixed up. Let's go back to the setup menu, to the mode menu by pressing the middle button again, and let's go to the band scanner. And I will also turn on the second sender again. So here it's scanning every second the band, and it tries to identify the current signal. And here you see it's pointing, this should be channel E1, and here it's switching a little bit, maybe E5 what is correct, but because the signal is so strong it sometimes pops up here with I think F8 or what, something like that. This is good when you are in the field and you would like to see what the current situation is. You get a good overview with a large screen, but the same scanner is also in the automatic menu. I press the middle button again to come to the mode. By the way, the band scanner, just to understand it correctly, is not showing any video images. The reason is, since this is scanning every second the entire band, you won't see any stable video because it's streaking or running through the channels very fast. So that's the reason why there's no background image here. When you tune with auto seek or with manual mode, you see always a background to see, yes, I've selected the right sender and I see my image, my video I would like to see. So back to the demonstration. I will go to the manual mode now. So selected this menu point, right button to enter. Here, right now my tuner is at 5.805 gigahertz. It's right here, and you don't see any image here because there is nothing. Now I press the left button, and now it's going through the channels here. You see right now I'm in the camera with a picture. I go back, left, left, left. Here is no video signal in the background. That's the reason why you see black. There is noise, but it can only show noise when it's it cannot show noise because noise has no switching signal. Let's move further when we come to the signal with a camera with a tank on it. So here, now you see the image in the background and the signal strength here. And what you also may notice is, as I mentioned before, when you tune, right now I tune linear, means when I press right, it will select the next available frequency, what in this case is band A. I do right next, next step right is raise band channel 3. Next band right is band B channel 1. Next band right is F channel 1, and so on. And every time when it changes the channel here, you see also the available channels here at the ground line. The nice thing is you see the spectrum, and you see probably your selected band, and then you can see which frequency can be used. The interesting thing is, why is this called linear mode? When you manual tune, we just go through all the frequency in a linear mode with increasing and decreasing frequency. By this we jump through all the bands, but you find any signal. And the initial rx5808 Pro version, when we had manual mode, was moving just through the bands and then choosing the next band and next band and next band. This is also implemented here because it's possible to change the manual mode. Let's do this right ahead. So I press a middle mouse button, middle key here to come to the mode back. Now I go to the setup, and the setup menu. You have here manual mode. By the way, here's a bug. Interesting, it's wrong. Text is wrong. I will fix it. So I just changed this from to should be band mode, not linear. The text is wrong. And let's go exit here. And it's interesting. It's just the initial text is wrong. Let's go back. Setup. Now I put this to band mode. Let's go back. Okay, now it says band mode here, so just it seems to be that the initial screen is just wrong. I will fix it. So here is manual mode, band mode. Now when I tune now, it will move within a band. Now it's doing B1, B3, 4, 5, 6, 7, 8. And now it's switching the band, E. And it's just going through the channels of the E, but the frequency is jumping. For example, E2 is here, E3 is here, E4 is here. So this is kind of stupid because it's jumping around. But if you have, for example, sending module just in, for example, in band F, you see the spectrum, and here you can easily decide what is the best channel. Probably between these two here, channel F4 is the best choice. So you go to F4 and you find the channel what is available. So that's the reason why the band mode is useful. Since I can select my frequency very simple. I prefer the linear mode, but the band mode is good if you have a sender in a fixed band. Then you can just scan here the frequency and make an easy decision what is your best channel you can select without any disturbance. Okay, let's go back here. So what we had is now the manual mode, the auto search, a band scanner. Let's go to the setup. In setup, you can see do the safe setting. Why do we need safe settings? Very simple. When you start up the system, you don't want to set everything up. A regular operation, a common operation would work like this. At the beginning, I do auto search. So here is my sender. This is E5. I would like that the system should come up with this channel. So what I do now, this is found. I go to the menu and go to manual mode. Manual mode, because if I would save the scanning mode, it will scan when I turn on the system. But in this case, it should come up with this here. That's the reason why I search the channel with search mode. And then I change to manual mode, tuning the same channel, and I will save this now. So that means I press a middle button and go to setup with right button, middle button, and then now I save this. And now I will turn off the system here, turn it off, and turn it on again. And now it will start with the manual mode with my channel I would like to see. That's if you have fixed channels, you would go with this way. But if I want, I can also go to auto search and we'll save this here. Let's do this. Saved. And now I'll turn off the system again. Turn on the system again, and it will start with a seek. This is not always wanted, but anyhow it's possible. So what else do we have in the setup menu? In the setup menu you can also change the video. The default, my current setting is PAL. I will change this to NTSC. This will change the OSD screen, but will not work with my cameras because they are PAL. But let's do it anyway. So this is saved automatically, and the notice says you need to restart. I will do this. On NTSC, the resolution is lower. That's the reason why you don't see any menu again. Here, no overlay will show up because the camera is doing PAL, but the OSD is NTSC. I will go to the mode menu. Let me see. Now, you will notice it's getting bigger here. And to demonstrate some things, I would like to go to manual mode here. You notice that there are less lines on the screen. This is almost out of the screen. The reason for this is that a monitor is always doing overscan, but if you compile the software by yourself, you can change the offset positions here in this direction to make it fitting. But what is good here to demonstrate is what happens if your settings are wrong. Oh, let me just change back to linear mode. Okay. Exit. Currently my menu here is set to NTSC, but the camera is PAL. So when I'm tuned now, I tune left. Now it's on the right channel, but because this is a PAL camera, it will not sync with NTSC, and that's the reason why we don't see any OSD here. So keep in mind that the camera video system and the OSDs or screen system must be the same, otherwise the OSD is not showing up, but it's still possible to control it. I will change back to PAL now. Okay, it's saved, and restart the system. Oops, this is supposed to be a no-cut video, but after 20 minutes my small Samsung video camera just stopped recording. Anyhow, let's restart it at where we left. So the last thing we have done, changing between PAL and NTSC. And now let's see what else can be done. We have two more features in the setup menu. There's also the receiving signal strength indicator calibration. Why do we need this? Every receiver has a different receiving voltage depending on the signal strength, and to have the right size bar, it needs calibration. So when I fire this, it will scan the band several times and finds the minimum, maximum, and saves it. Let's do it right now. So it's scanning here, the minimum value is here, the maximum is there. It's doing this 5 times, I think 3 or 5 times, I don't know. And now the new maximum value is saved, and the maximum value is required that this here has the right size, and it also sets defines how large a minimum signal could be to see the channel indication, what is automatically discovered. What else? The last function here is the font upload. Why do we need this? Let's talk a little bit before we go to this. Let's talk a little bit about how this is technically done. So in the rx5808 Pro project, we use the great TV Arduino library. And this has a low resolution graphical interface. That means I can really draw lines, paint rectangles, place text everywhere, to have full freedom to create a spectrum analyzer. But the OSD is based on characters. That means you have a fixed grid here with all the characters, and there are no graphical elements. I can't draw a line or something like that. So the solution for this problem is use special characters. That means I create special characters to create this vertical bars, to create these dots here, this arrow, and this small markers here. So this is a very common concept. Most of you know already how the OSD is working on multicopters. They create arrows and even artificial horizon out of characters, and that's what I've done here. But one special thing is, since I have a fixed resolution and I have fixed number of columns here, every column really does not reflect one frequency. It's interpolated that I have interpolated a number of channels in the given number of characters. What I did in software is that indeed one character is always 2 bars, and with a lot of different characters I can create virtual 2 independent bars here. If you're more interested in, check the char set, check the source code. Interestingly done, but that's the reason why the frequency is sometimes jumping around, not showing the exact position, but it gives you a good idea where the spectrum is and how it looks like. But bottom line is, when you buy a OSD, you have a firmware on it. The firmware has definitely the wrong character set, and it must be uploaded. On other projects, there's a special software where you can configure your appearance of your OSD, and there's also upload feature. Here I added just a simple font downloader taken from other projects, and I will just upload the font from Terraterm, what is a free terminal program, and the Terraterm you can send a file with the UART connection. Let's do it right ahead that you get an idea how it looks like. And again, this is required one time, otherwise you get messed up characters. For uploading, you need FTDI serial adapter. All of this, what I'm telling right now, is described in the wiki page, but this is for absolute beginners. No, it's more for more advanced people, but it's doable. Anyhow, let's do a font upload once. So what happen here is I go to setup, and here's the font upload feature, and I start this here. So this is now bringing the software in a special mode where it's expecting characters on a serial connection. Okay, I missed something up. When I started the Terraterm, it's connecting with the, with the FTDI adapter here, and what happens, it just resets the Arduino. That's the reason why I jump back. So let me just move the camera just one time. Oops, hopefully it's not too shaky. Here is my Terraterm, and you may notice that it's receiving characters for unknown reasons. The reason is I'm sharing the UART connectors also for the keyboard, and since the keyboard gets spoiled, it seems to create characters here, but it's just interpreted by the Terraterm. Let's go back to here. So again, I go back to the menu here, setup. The Terraterm is doing crazy, by the way. I say font upload here, and now I go back to the Terraterm. You see all the stupid characters are sent here, and it's waiting for sending now the file. So I say send file. And here is a character file, what is a so-called MCM file. I say open, and now it's sending the characters. Takes some seconds. Dum-de-dum-de-dum, yes, yes, yes. But you have to do this just once. In case of updates of characters, it will be noticed on the web page that you know that you should do it. So it's done now. Yeah. Anyhow, this should be done only once, but the function to do this upload is inbuilt into the software. So I think we are done for now. This video will be uploaded to YouTube. I will put a reference on it. Where the GitHub wiki page is found, and the source code and the compiled and everything. Yeah, hopefully enjoyed it, and I think it's a good autumn project to pimp your OSD receiver. One final note: some of you guys may notice this one here. This is a diversity 4-channel receiver. The German community did a project, I think 2 years ago. I added also the receiver in here. On the web page you find some photo series showing how to take this 4-channel diversity, put this OSD in here, and how this can be patched and how this can be used. So it's easily to integrate, it fits to here, and then you can pimp your device what has already some years of operation. So I think we are done now. So hopefully enjoyed this. If you build your project, if you would like to improve it, just contact me. You're welcome to work on the wiki or on the GitHub. So greetings from Germany. This is Marco, and have fun and build it by yourself.